It says find the length of AB. Each square represents 1 unit. So how many units would AB be? 6. Okay, because I do it 1, 2, 3, 4, 5, 6. It'd be 6 units. All right, AC. So from A to C, how many units would that be?
10. 7. I got 9. I got 10.
Okay, 10, 7, 9. So is there really an accurate way to know exactly what that length is just by looking at it? No. So we don't know what it is right away.
How did you count? Yeah.
Okay, how did I count, like AB? You're really not supposed to because it's diagonal. So it doesn't go through any square exactly the same amount of time. So we don't know. But now it says explain how a right triangle could be used to help you answer part B. So how could a right triangle help me figure this out?
B to C.
Okay, no numbers, no specifics.
B to C.
If I made this, if I made it a right triangle, I could use the Pythagorean theorem to find the length of AC, right? So by creating a right triangle, Connor, I'm writing, you're not. You're looking around the room smiling at people. The diagonal is always what? Question mark.
C.
Is always C, okay? What is C? What is the technical name for that?
Longest.
No, starts with an H. Hypotenuse.
Whatever it's called.
Okay, the other ones are the legs. All right, so it says to find a diagonal distance on a coordinate plane, create a right triangle where the diagonal distance is the hypotenuse, or C. So then use the Pythagorean theorem to calculate the diagonal distance. Okay, so if you look, it says in 1 through 3, use the Pythagorean theorem to find the distance between points A and B on each graph, round to the nearest tenth. Okay, so I have 2 points. Connecting them would be what?
Negative.
That'd be my diagonal. That'd be my C. That'd be my hypotenuse, okay? So using that as my hypotenuse or my diagonal, I need to make a right triangle. I went like this. Okay, and then somebody asked me, do we have to do it that way? Can we make it a different direction? If you want to make your right triangle this direction, that's fine too. Okay, but a right triangle has to have what?
Equal to 190.
A 90-degree angle, right? Has to be exactly square. Okay. Now, each square represents 1 unit, so I need to figure out my side lengths, right, to find C. So I have 1, 2, 3, 4, 5. And then I have how many on the top? 4. Okay, so using my theorem, a squared plus b squared equals c squared, what 2 numbers would I plug in? 4 and 5. So 5 squared plus 4 squared. Okay, so if I do 5 squared plus 4 squared, it gives me 41. What do I have to do to 41? Okay, because it's saying 41 is equal to c squared. Well, I want to know what c is without the square, so I have to square root it. Okay, it said round to the nearest tenth. So what is the nearest tenth? 6.4. Okay, what do these little squiggly lines mean? Around, about, approximately. So if we round, if I put an equal sign, is that technically correct? It is not equal to 6.4. It is approximately about 6.4. Okay, so from A to B. Now this is going to be a long, slender triangle. What do I need to know? Okay, that's 2 at the bottom. 7 on the side. So what do I do with 2 and 7? Plug it in. So 2 squared plus 7 squared equals c squared. So then my calculator, 2 squared plus 7 squared. What do I do to 53?
Square root it.
Square root it.
7.3.
3. Why is it 3 and not 2? Okay, that 8 makes it go up to 3, so 7.3. Okay, so from A to B. Yeah, that's a big one. All right, so to go from the very bottom up to B, how many squares do I have? 8. Okay, what about at the bottom? 8. So I have 8 squared plus 8 squared is equal to c squared. What do I do to 128? Square root it.
11.3.
Okay, 11.3. Pretty much. Pretty much. Okay, so it says triangle EFG is shown on the grid. Find the length of EG. So it's the same thing. Okay, EG. So I need to know this is what? 3. This is?
You can't count.
Yes, you can.
Oh, you meant up.
3 squared plus 9 squared equals c squared. So it gives me 90. So I have to square root 90.
That's
9.486.
Okay, so 9.486. Is that what I need? 9.5.
Oh, but now we got a graph.
Can we just put it on the calculator?
There is a formula, but it's easier to mess up the formula than it is to graph.
Wait, what was the number?
Okay, so right here, it says use the graph and the Pythagorean theorem. Now, I even went back and looked on previous STAR tests, and it has done this multiple times. It's given you a graph, and it gives you 2 points, and it says find the length of the diagonal. Okay, so I have to plot these points on the graph. So I have -6 and 1, and then -4 and 5. Okay, so I draw my diagonal, and then I create a right triangle, and then I solve. So I have 4 and 2. So I'm going to have 2 squared plus 4
So you're
squared.
never gonna do the diagonal one.
What do you mean? Like solve for the diagonal, or it gives you the diagonal and solve for a leg?
Yeah.
No, not on a graph. Because I can't, like, that's the whole point to this, is I can't count from here to here. I won't ever know it without solving
So
for
we're
it.
only gonna solve the legs.
We're always going to solve for C. Okay? So 2 squared plus 4 squared gives me 20. So what would my
4.8. No, 5.
4.5? So 4.5 is equal to C, not even squiggle. Okay, so I have -7 and -7. And then I have 4 to negative 3. Ooh, I did that wrong, didn't I? Nobody called me out on that. Negative 7 and 7, it's a 4 to negative 3. Okay. So when I do that,
10, 13.
I have 4 squared. Is it 4 and 10 or 4 and 11? I think it's 4 and 11. 4, 5, 6, 7, 8, 9, 10, 11. So I have 4 squared plus 11 squared.
How did you get that one that goes off to the side?
Because I messed up. I plotted the wrong point. I did negative 4, negative 3. That's why I said nobody called me out on that, because it was 4, positive 4, negative 3.
Is it okay if your triangle like upside down?
Yep.
Would you get a negative?
No, because when you're finding the lengths of something, a distance cannot be negative.
Is it always
Okay.
gonna be a decimal?
Not always, not necessarily, but a lot of the times it might be. Okay, so C, my C is what? 11.7. Okay, so I have 0, 2. So if I have 0, I have nowhere to go for X, and then I just go up 2, and then 7, 7. Okay. How many, what are my 2 leg lengths?
7 and 5.
I got 8.6.
Okay, so 7 squared plus 5 squared, so 8.6. Questions so far? Feeling okay? Not too bad? Pretty easy?
Are we always gonna have to put this frugally X?
You need to get in the habit of it because you need to know the difference. Because 8.6 is not exact. It was not equal to exactly 8.6. This is telling me that I rounded.
Exact number, you put the straight number?
Yes. Yes.
Is it gonna get harder from here?
It depends on your definition of it being more difficult. I think you have to think a little bit, but it's not, the process isn't any more difficult. So look, the pentagon on the grid represents the front view of a dollhouse in Kaylin's toy room. Use the grid to answer A through B. If each unit on the grid represents 1 centimeter, list the length of each segment below. Well, right here, I don't know AB. I have to find it. Do I know AE? Yeah. Okay, so 1, 2, 3, 4, 5. So this is 5. What do you think that makes this? 5. Okay, DE is what?
12.
1, 2, 3, 4,
12. Okay,
5.
so A, B, and BC, is it possible for me to find that?
No.
No.
No, because they're horizontal.
They are, but what can I do to find it?
Right angle.
Right angle. Right triangle. Okay, so my bottom part of my triangle is how many units?
6.
6. What about my side? 7. Okay, so what would I do with 6 and 7?
85. Square root it.
Okay, so 6 squared plus 7 squared.
I think it's 6 and 8.
Is it 8? It is 8. This is 8 because it goes down to 1.
Are we recording?
8. Okay, 100. We know what the square root of 100 is.
So BC would be the same thing.
Why would BC be the same?
Because they're equal.
They're the exact same triangle, right? So it is also 10. So it says find the perimeter of the pentagon. Add them all up. So if I added all my segment lengths together, 42 centimeters.
42.
So if it's like horizontal, you can't do it.
Horizontal, you use the Pythagorean theorem to find.
Are we gonna have a conflict on,
Kind of. Do you have a question, Gabby? Let's get through this problem first so you see how to do it. Okay, in the graph below, point A represents Araya's house, point B represents Bridget's house, and point C represents Capri's house. Each unit on the graph represents 2 miles. This right here is super, super important. Okay, to the nearest tenth, find the distance.
Kaylee, Maddie, Shayla, Jimena to report to the junior high science lab for UIL.
I'm guessing Shyla, they meant you.
Shayla?
Okay. All right, so the most direct path. If I were to go from point A to B, my most direct path would be to go straight like this, right? But I can't find that distance without doing what? A right triangle, okay? All right. Look, it has a right angle right here.
I connected C.
Okay. So I have how much from here to here?
11 and 5.
Okay, I have 11 and 5. So I have 11 squared plus 5 squared. Which gives me what? Okay, so when I square root that, I get what?
12.08. So it'd just be
12.1.
12.1. Okay, so then bridge it to Capri. So B to C. Okay, so then I make another triangle. And I have 1, 2, 3, 4, 5. Ooh, we're not doing something right. I know, because that's why I just remembered. You know why? What does each unit represent?
2. So couldn't you just times that by 2?
So it's 9 and 5, so 12 times 2. Did I get 24? Or 24 point something?
24.2.
Because you put 22 squared plus 10 squared.
Because we doubled it.
Yeah. So you multiply it by 2.
Because each one represents 2, not 1. Okay? So 22 squared plus 10 squared.
So each unit is 2 miles.
So this is 24.2.
So I guess really you could have just did it the original.
Yeah, 12.1 times 2. Yeah.
Multiplied it by 2.
Did you do that?
It worked either way. So like here, I could do 5 squared plus 9 squared. And then multiply whatever I get by 2. So 5 squared plus 9 squared. 106. Square root. So I have 10 point what? 0.3 times 2. 20.6. Is that right? Butler, is that what I got? 20.6? Yeah. Okay. Now A to Z. Okay, that one looks real weird compared to the other ones, right? Okay, so that bottom part is 2. And then I have 1, 2, 3, 4, 5, 6, 10. So 10 squared plus 2 squared. So 10.2 times 2, 20.4. Was it 20.4 or 20.3 on that paper? 0.4? I like that. Okay. I think a lot of you do really well with visual representations of it, and y'all counting and just finding C.
I get it.
Helps. You get it. Yay.